in proof by induction. On the other, and questions with factorials do come up a lot in proof by induction as well. Yeah, deduction. Deduction is the main one that you'll do, where you just work it out in algebra and left hand side equals right hand side. We kind of use deduction here too. A contradiction is where it's like prove that. Remember we did it for an irrational number, and we said, all right, let's assume it's rational and see what happens. And then you figure out when you assume it's maybe you're absent, but we remember it was the p over q. Root 2 is p over q, and then we found out that it actually had factors, even though it was fully simplified. If you remember that, you've contradicted your statement at the start. Okay, let's do. This is definitely the most asked type, proof by induction. Okay, so we got to do these 3 steps. First of all, we're going to test it's true. Test what's my base case in this case, and this is where you look at the question. This is my base case. N is 0 in this case. So test for n equal to 0. Does it work for n equal to 0? Yes. Yeah. That's you maybe didn't see that. So let's test. 4 to the power of 0 plus 2 equals 1 plus 2, which equals 3. Or 1 plus 3. Oh, it's bad, yeah. Which is equal to 3, which is 3 times 1, so therefore it's it's true.
3 is a factor there.
3 is a factor, okay. So it's 3 times 1. It's 3 times something, it's factor. So when you're proving divisibility, this kind of thing of a factor is important, that it factors out. Because that's how you prove it's divisible. It has to have a factor of it. Okay? All right, we've done that. Let's assume it's true. So this is always an easy step. N is equal to k, so 4 to the k plus 2. Now what do I write? How do I say that? Equals, and that's why I wrote this like this. Is equal to 3 times something. Don't use k because it mightn't always be the k. Is equal to 3 times something.
A is something?
Is something, yeah. Yeah. Just as long, you can use b, you can use a letter, you can use a different letter, any letter here. Okay, where a is some integer. You could use b, you could use c, you could use q, p, anything. It's 3 times something. That's what you're trying to. That's what you've assumed. So now let's look at the third step, which is to prove. Okay, which means I have to write 4 k plus 1 plus 2 is equal to what? So we don't have to say it's equal to anything. What we're trying to show in this case is there's no right-hand side here. There wasn't at the start either. We're just working on one thing. There is a left and a right here, I suppose. But we really have to show that at some stage we can write this as 3. Okay, then we want to write that. Yeah? It's 3 times something. And that's us sorted as it's divisible by 3. So how do we work out this down into 3 times something?
Can you simplify it to 4k times 4?
Yeah,
And then if 4k.
I think you have it, yeah. So we have to, remember, we're going to use the assumptive step at some stage. We're going to use this in this. And we can't substitute it in just yet. But Josh had a good idea. He was saying that if you could rewrite this as 4 to the power of 1 times 4 to the power of k. My 4s are weird. Plus 2.
Yeah, 2 is better.
Let's do it as 2 to the power of 2k plus 2.
Yeah.
What? You can substitute 4k minus 2.
Yeah, I want to do something with this. Remember with the other example, I ended up substituting this in, the right-hand side, into the left-hand side of the previous example. That's kind of what I want to do here, but there's a problem, isn't there?
Oh, we have 4K plus 2.
You 4 times 4K and then add 2. You don't have 4K plus 2. You can't just say, there you go, because that 2 is not multiplied by 4. But that's what I want to do. I do want to find this to replace here somewhere, because I'm going to replace it with 3a if I can find it here. How do I just work it in? Well, watch this. No, it's just, what happens if I did just put it in? How have I changed it? As long as it's a bit like when I do completing the square. I've changed it. How have I changed it?
Times by 4.
Yeah, it's 8.
Plus 8.
So
Plus 6. Plus 6. So you add 6 to the other side.
So I add 6?
Yeah.
Does that equal this statement?
No, I mean to the other side, to 3a.
There's no equals here. Minus 6? Is that the same statement as before?
Yes.
Because 4 times this, 4 times that makes 8. Take away 6 is still 2. So that's 8, take away 6 gives the 2. Okay, so it's the same statement, but now what happens here? 3a. Okay. So that's 4 times 3a.
Then that's divisible by 3.
Yeah, you're there. 4 times 3a minus 6. From assumption, or from assumptive step, or from step 2.
We have to
A k, sorry, I put a k. That's an a. Yeah.
We have to write that down like from assumption.
Yeah.
when we
Yeah.
do it.
Yeah.
Oh, what? That's
It's just, you're going to use the assumptive, that's the induction hypothesis it's called. So you're going to use that step at some stage. Now, we haven't fully done it, but we're almost there. So I want to make sure that it's divisible by 3, so we get 12a minus 6, yeah? 12a minus 6. So I'll factor out 3, and I get 4a minus 2. And therefore,
Let's go. 3 dots.
3 dots.
Yeah.
Minus 6 came out of nowhere, yeah. Yeah, we went through this. So I want to put this in. I need this as one statement so I can replace it with 3a. But at the moment, I just have 4 times 4k, or 4 to the power 1. So that's 4 times 4k. But I want it to be 4k plus 2. This 2 is not multiplied by 4. See that? So what happens if I just say, I'll just do that step again so we watch it. What happens if we just say, right, I want to say 4k, 4k plus 2. I'm going to just say that. But that's really, if I multiply that out, that'd be 4 times 4k plus 8.
Yeah.
That's not the same as this. I've put too much in. So if I just put a minus 6 after this, and then the minus 6 would be here, and I'd